In section 2.5, we are going to start with similar figures. Up until now, we've talked about congruent figures, and congruent means when you have the exact same shape and the exact same size. So here's your key idea. The first part of our key idea is to define what similar figures are. Similar figures have the same shape, but their sizes are different. So same shape, different size. That's what you call a similar figure. So let's do a diagram. Draw these two triangles down. We have two triangles, triangle ABC and triangle DEF. They're the same shape, but they're different sizes. Now, as you notice, it's very important to notice here, the angle B and angle E are the same. Angle B and angle E are the exact same. Angle A and angle D are the exact same. Angle C and angle F are the exact same. That's why we have these marks. These have a one little mark, these have three, these have two. Therefore, the angles are the same. Now, in order to say that things are similar, we're going to state that these two triangles are similar. We're going to say triangle ABC. Now, similar is just a wavy line. Is similar to triangle DEF. So that's how we would say that two triangles are similar. So in words, here's what it means, and these are two really important things you need to know. Two figures are similar when corresponding side lengths are proportional and corresponding angles are congruent. So keep in mind that we have angles that are congruent and side lengths that are proportional. So I'm going to make room for one other piece of information. So I'm going to move these up. Here's what it says. Your side lengths. Your side lengths must be proportional. And what that means is corresponding sides. So let's start with AB. Now, that means the length of AB, which is this. AB is proportional to, not the same. AB is proportional to DE. And what that means is we can write it as a fraction. So AB is proportional to DE, which is then, if we do two more sides, we could say side length BC over side length EF, which is also equal to side length AC divided by side length DF. All of these fractions must be equal, every one of them. If they're not, you do not have similar figures. We also know that the angles are congruent, so we can say angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. So this is your key idea. Please make sure you study and know this. Example number 1. Which rectangle is similar to rectangle A? Now, rectangle A, if you look at it, has a ratio or 3 to 6, or a height to width of 3 to 6, or you could say a length of 6 and a height of 3. But we have to see which rectangle, B or C, is similar to rectangle A. So each figure is a rectangle. So we know all of the angles are already congruent. All of these angles are 90 degrees, all of these angles are 90 degrees, and all of these angles are 90 degrees. So we cannot use angles. We have to see if their corresponding sides are proportional. So here's what we're going to do. We're going to start with rectangle A and rectangle B. So the length of rectangle A is 6. The length of rectangle B is 6. So what I'm doing is this, 6 over 6. We know these must be proportional. So 6 over 6 has to equal 3 over 2. Well, 6 divided by 6 is 1. 3 divided by 2 is not 1. Therefore, they're not proportional. And another way to check it is to, like for example, you could say, well, 6 divided by 2 is 3. 6 divided by 2, well, that doesn't give me 2. Or you can cross multiply and say 6 times 2 is 12. 6 times 3 is 18. They're not equal. So we know rectangle B is not proportional to rectangle A. So let's look at rectangle C. Rectangle C has a length of 4. So rectangle A has a length of 6, and the corresponding side is 4 on rectangle C. 6/4 can be divided by 2 on the top and bottom, so that would give me a ratio of 3/2. Then the length of this side, or the height here, 3/2, that's a ratio of 3/2. That's already simplified. Notice that the ratios are the same. You could have also done this. 6/4, that's this, 6/4 equals 3/2. Are those the same fraction? Yes. 6 divided by 2 is 3. 4 divided by 2 is 2. So that works. Or you can cross multiply and say 6 times 2 is 12. 4 times 3 is 12. Therefore the same thing. So our answer would be rectangle C is similar to rectangle A. In the next 3 examples, we're going to find the value of x, knowing that our shapes are similar. So I want you first to draw 2 similar triangles. One triangle has side lengths of 6 meters and 8 meters, and another has side lengths of 9 meters and x. So we have to find the missing side. So here's all you need to know. We know that these are similar. Therefore, this side and this side and this side and this side can be set up as a proportion because we know they should be equaling the same thing. So we could say 6 is corresponding to 9 and 8 is corresponding to x. Now last year in 6th grade, 6th and 7th grade, you learned how to solve proportions. We cross multiply. 6 times x is 6x. 9 times 8 is 72. Divide both sides by 6, and you get a value of 12 meters. So the side length, which is x, is 12 meters. Example number 3. We have 2 similar triangles again. So now we have to find the proportionate sides. So we know this side here is proportionate to 9, so we could say 6/9 equals, now remember that if we're starting with 6, that means we're starting with the small triangle. So I have to do 6/9. I then have to do x because we're starting with the small triangle again, x/6. Cross multiply, that gives us 9x equals 36. Divide by 9, the value of x is going to be 4, so our missing side is 4 feet. One more. Number 4, we have 2 trapezoids. So we know that they're similar. So what would I do here? What 2 fractions would I write? Well, you could say 14 and 7 because they're corresponding, and x/12. Cross multiply. 7 times x gives us 7x. 14 times 12 gives me 168. Divide both sides by 7. The value of x is 24, and therefore the missing side would be 24 centimeters. Example number 5, you do not need to write this down. You can if you want, but we're going to go step by step on how to do a real-life problem. So let's read this together. An artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid, which is this right here. In the replica is 3.75 inches. That's right here. What is the height of the trapezoid in the replica? So here's what we know. Because the trapezoids are similar, corresponding side lengths are proportional. So we have to write and solve a proportion to find h. So here we go. You could say, what 2 sides line up? Well, the 15 and the 30.75. So you could say 3.75 divided by 15, which is this, equals h divided by 12. I times both sides. Here they times both sides by 12. and they got h equals 3. Now that's one way to do it, but I want you to do another way. So this I want you to write down. Let's say you started with 15. You could say 15 over, well, 15 and 3.75 are corresponding, so we know they're proportional to side lengths 12 and h. So we could say 12 over h. So you could cross multiply. They didn't do that here, and that's okay. They just got rid of a divide by 12. If you notice, they did the opposite of divide by 12 is times 12. And they took 12 times 3.75 divided by 15. But let's cross multiply. That gives us 15h, and then we have 3.75 times 12, which gives me 45. I divide by 15, and I also get 3 inches. So there are multiple ways to do a problem. So remember once again your key idea. This is the one thing I want you to know from today. Similar figures have the same shape, but not the same size. The angles are still congruent. The side lengths are proportional.